Someone please ask Deepali to join again. She has been removed. Yeah. So let us see this problem. Look at this problem. This is the handshake problem. So there are n people in a room, and um, in this room, we wish to count the number of handshakes. Okay. Given this condition, the condition is that if each person shakes hands once with every other person. So a person is going to shake his hand once with every other person, and you want to find out what is the total number of handshakes, h of n, in this case. Okay, so if for these n people, what is the total number of handshakes given that each person will shake hands once with every other person? Okay, so a room filled with people. So let us start with the simplest example. So that there are two people in the room. Suppose there are two people in the room. What is the number of handshakes that we have?
One.
One.
One, right. Now a third person comes into the room. According to this condition, what should happen? Each of these people should shake hands with the third person, right? So the number of handshakes which are added to this now becomes two. So two handshakes are added to the original one handshake, right? So I can express this as when there are three people, that is n is equal to 3. For three people, that is h of 3, the number of handshakes, h of 3 is equal to the number of handshakes when there were two people plus two handshakes, correct? Now what if a fourth person comes into the room? What will be the number of handshakes?
6.
6. But in this expression, in terms of this expression, what will it be? H of 4. What will h of 4 be? Using h
H
of
of
3.
4
H
is
of 3 is
equal
already
3
there
plus
with
3.
us, right?
H of 3 plus 3.
H of 3 plus 3. Very good. Because for the fourth person, all these three people are going to shake hands with him, right? So this is how it goes on. So for a fifth person, you should guess what it is. And eventually, when the value goes on to n, what will be the formula?
H of n minus 1 plus n.
Very good. Is this clear to you? Is this clear to everyone?
Yes, ma'am.
Yeah. So what we have done is we have expressed this handshake problem, okay, that is h of n, in terms of itself, right? We are again saying it is h of n minus 1. We are expressing this handshake problem in terms of a smaller version of itself, because n minus 1 is a smaller number than n, definitely. Okay. And we are writing some kind of a formula here. Okay. Which in through which we are able to get the correct handshakes. And we see that if we apply this formula, you give any value of n. So now if n is 100, if you apply this formula, what will happen? You need to keep on substituting the value in this formula for n. Okay, so suppose, let me not take 100, it will be too much because it will take time to compute. So suppose n is 6. Okay, so if n is 6, if I use this formula, I can write it as h of 6 is equal to h of 5 plus 5, right? And then for that, for finding h of 6, I need to know the solution to h of 5, okay, which is nothing but h of 4 plus 5. I'm just substituting this. Is there any problem?
No, ma'am. No, ma'am.
No.
Okay. and then I keep on substituting, right? So this h of 4 again I will substitute h of 3 plus 3. So are you getting the substitutions that I'm writing here? And then h of 3 will be h of 2 plus 2, and this will be 2 plus 3 plus 4 plus 5, right? Then h of 1, h of 2 will be h of 1 plus h of plus 1 plus 2 plus 3 plus 4 plus 5. Okay, but I do not need to go down till 1. I need to stop here, right? Why? Because I know that the solution to h of 2, I know already what is h of 2. What is h of 2? H of 2 is 1, right?
One.
I know the answer to h of 2. So I'll stop this substitution till I reach a case for which I know the answer surely. And that will be a very small instance of the problem, because 2 is a very small value of n, right? Some instance, some other problem, it could stop at h of 1. Depends on the problem. Now in this problem, we know that the smallest instance of this problem for which the solution is known as 2, n is equal to 2. Okay, so this way of solving a problem that we just saw, of expressing the problem in itself, okay, in terms of smaller versions of itself, is known as recursion. This way of solving a problem is known as recursion. Okay, so of course we know that this can also be solved, this problem can also be solved in a very simple way by using this formula. Okay, right? But this is one way of expressing or solving the problem. Okay, so let us see what is today's topic. Today's topic is nothing but recursion. Now recursion is closely related with functions, because whenever we write a recursive solution to a problem in terms of a program, we will always write a function which is recursive in nature. Okay, so recursion is useful for problems that can be represented by a simpler version of the same problem. For example, a very simple example of recursion is the factorial function. Okay, so factorial function we have already solved, right? We have already solved using a loop, right? Loop means you have used either for loop, you must have used, right? For loop or while loop also you can use. But can you think recursively for solving this factorial problem? That is the question. Okay, so can you express the factorial problem in terms of itself? If you can do that, then you can solve the problem using recursion. Okay, so you know that example in this given here is 6 factorial. Everyone knows the formula. 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. But we can also write 6 factorial as 6 into 5 factorial, right? Okay, so in general, we can express the factorial function as n factorial is n into n minus 1 factorial. Everyone knows this. Okay, but when we write a recursive solution to any problem, we do not stop at this formula. We also need to define one more thing. That one more thing is when this recursion should stop, because you saw just now, you saw the handshake problem and I told you you have to stop at some point. You recollect? You have to stop at some point. You have to stop at a point where you know the solution sure shot. Okay, and that is the smallest instance of the problem. Okay, so this solution will be complete. The recursive solution to the factorial function will be complete when we write the smallest version of the problem. When we write that as well. Okay, so we should write that n factorial is 1 if n is equal to 1. N factorial is n into n minus 1 if n is larger than 1. Okay, so this is how you express the function, any function, recursively. You have to mention two things. One is the recursive formula. So this is the formula, right? This is a kind of a formula that we write. This is known as a recursive formula. And the second thing is when your recursion should stop. The smallest instance whose solution you know, that is n factorial, is 1 when n is equal to 1. So both these things are important. Without adding these things, it is not possible for you to write a recursive solution to a problem. Okay. So how do you write this? Now this is the logic, right? Now let us see how do you write this function in terms of C as a C function. Okay. So it is simple. What you do is, everyone knows how to write the function definition, the prototype, the signature of the function is known to you, right? How to write it. It is return type followed by the function name, and then you have the parameters, right? A parameter will have the type, corresponding type, right? So that is fine. This is the signature of the function. Now inside this, you are required to write the body of the function. So when you are writing a recursive function, then in that case, what you do is you write the same thing that you saw earlier. You saw this, right? If n is equal to 1, answer is 1. If n is greater than 1, answer is n into n minus 1 factorial. The same thing now you have to express into C code. So what you will do, if number is less than or equal to 1, or you can say equal to 1, why we are writing less than equal to 1 is for handling 0 as well. So if number is 0, then directly 0 factorial is 1. Okay. So if number is less than or equal to 1, your function should return 1. Else, your function should return number into factorial of number minus 1. Now this is very important. So what we are doing is, we are writing in the return statement. This is fine, right? Everyone has seen this kind of a return statement where we are simply returning some constant value. This is fine. But in the else part of it, what we are doing is, we are writing the recursive formula. The recursive formula was n into n minus 1 factorial, right? The recursive formula was n into n minus 1 factorial. Okay. So this formula, in the second part of it, what is this? This is nothing but the function itself. But the function is now called with an argument of n minus 1, right? The argument that you need to pass to this function call is n minus 1. So what we have here is, in the return statement only, we write the formula, and the formula contains a function call. What is this? This is a function call. Everyone agrees, everyone knows, no? This is a function call, right?
Yes, ma'am.
Okay. So the function call is written, but the difference is, in the function call you are passing one, the call, the argument that you're passing is a lesser number, right? It is number minus 1, n minus 1. That is of importance when you are writing a factorial recursive function for factorial. Okay. Recursion means that a function calls itself. So what is happening is, a function is calling itself with an argument which is lesser than the original argument. Okay. So we will see how this works actually, the function call. So suppose this is my function. This function you can see, which is written down in the square at the bottom. Okay. So suppose this function is called. Now this function that you have defined, fact, this you're going to call from main, suppose. Okay. So in main you write the program. So int main you write, right? Int main, and inside main you are saying you're giving a call to this function. Okay. And of course this will be something like, right? The call should look like this. Everyone agrees? The call should look like this or no? The function call. Okay. And of course you have your return 0, blah blah blah. This is fine. Now for this function, this particular function call inside main, how this function will run in the background? How does it work? How does it work in the background? So first of all, it will start running, right? So what is the first statement that it encounters? If the number is less than or equal to 1. Is this condition true?
No.
No, this condition is not true. So it will go to the else part. Okay. So what is the else part? You substitute. Okay. It is 3 into, because 3 was passed to it, 3 into factorial of 3 minus 1. That is factorial of 2. Okay. Again. Now what has happened here is, there is a function call, right? There is a function call to factorial with argument 2. This is the function. Now, since this is another function call, what happens in the background is, again the function starts running with this value 2. Okay. So now factorial 2 will start running. So for factorial 2, what happens is, again this condition is checked. So is 2 less than equal to 1? Okay, let me explain it like this using something else. Might be difficult to visualize this. I will use, fine. Okay. So what was our function call? Our function call was factorial of 3, right? So now for this factorial 3, what happens is, your factorial function starts running. Okay. The factorial function starts running with value 3. Okay. So inside this factorial function, what was the first statement? If factorial, if that number n is less than equal to 1, you return, but it is not true, right? So it goes to the else part. So this function has a call to factorial 2. So this function now, factorial, starts running. Another function starts running now with the argument 2. Okay. Now for this function, this particular function, what happens is, again this condition is checked. So is your number, is n, what is the n in this case? It is 2. Is n less than equal to 1? No, it is not less than equal to 1. So what happens? It goes to the else part again. Okay. So it goes to the else part, and else part says return n into fact n minus 1. Okay. So what happens is n minus 1. Okay. Now for this, another third function starts running. Now this function, for this function, what happens? The if condition is true. Yes or no? The if condition is true for this particular function.
Yes, ma'am.
So because
Yes,
of
ma'am.
that, so what is written in that? Return 1. So this function, this particular function, fact with 1, is going to return a value 1 to the function who called this function. Which function called this function? Fact 2. Fact 2 called this function, right? See, understand that whenever there's a function call, there's a separate copy of the function which is running in memory. Okay. Whenever there's a function call, a separate copy of the function starts running. So if you're calling the function 10 times with 10 different arguments, the same function fact, okay, you're calling with 10 different arguments, 10 copies are running. Okay, they're different, they're mutually exclusive. Are you getting it? This has to be there in your mind. This has to be fixed. So what is happening is, fact 3 is calling fact 2, fact 2 is calling fact 1. Correct? This is clear now? How it is progressing? Fact 3 is calling fact 2, fact 2 is calling fact 1. Now fact 1 has done, because fact 1, the first condition is true, so it returns a 1. Okay, now it returns a 1 to where? Whenever you call a function, there is a return statement. So when you call a function from main, main will get the return value, yes or no? Because you're calling from main. Because the calling function is main. Now in this case, which is the calling function? The calling function is fact2, right? So this one value is returned to fact2. Now what was the statement? If you go back to fact2, what was the statement written inside fact2? It was 2 into fact1. ऐसे call था ना? This was the call. Yes or no?
Yes, ma'am. Yes, ma'am.
Ah. So
Yes.
this fact1, from here there was a call, na? This was a call, so it jumped here. Now this fact1 is getting the value back. So this is resubstituted with 1. That is what happens. 2 into 1. What is the answer? 2. Right? So now this particular computation is complete for fact2. Fact2 is done because 1 has returned back. So the computation is done. Answer is 2. So what is the return statement? Return 2 into fact1, which is 2. So return 2. So this value 2 is now returned back to fact3, who called it, right? So fact3 had a statement 3 into, yes or no? Fact3 had this statement.
Yes, ma'am.
So this value 2 is returned from fact2 to fact3. So now substitute. What is 3 into 2? It is 6. This is 2, na? So 3 into 2 is 6. So this value 6 is now returned to, from where it was called. This is main. This is main, right? Yes or no? So 6 is returned to main. And finally here you have written f is equal to fact of 3. So what will be the value of f now? It will be 6. Okay. So this is how recursion works. So recursion works by a function calling itself with smaller versions. So you can see fact3 is calling fact2, fact2 is calling fact1, and so on, till that smallest problem is reached where for which the solution is known. So that function call where the solution is known, in this case is fact1, n is equal to 1. Okay.
Ma'am, I had a doubt
Yes.
regarding after the function call, it will return to the main function, no? So
Yes. So
how
that
the
is the
function,
main function.
but how then factorial 1 is returning the value to factorial 2? It would return to the main function.
No, no, no. It is not like that. See, whenever you have, there are two things. Whenever there's a function call, there are two parts. One is the function which is called is known as the called function. Okay. There are two entities, I can say. And the second entity is called as a calling function. Okay. Now, what is a called function? Called function is the one which you're calling. Okay. So in our case, which is the called function? It is factorial, right? Called function is factorial. Okay. Calling function initially, which is a calling function? It is main, because main made the call. Main made the call to fact initially. Yes or no?
Yes, ma'am.
Okay. Now, whenever a function calls a function, the return statement that is there inside that called function, that returns back to the calling function. Whoever called it, whichever function called it, it will return back there. Now in our case, what is happening? For the first call, main is calling fact3. So that fact3, whatever fact3 will return will go back to main. That is correct. But in our case, since we are using a recursive function, fact3 is going to call fact2 and fact2 is going to call fact1. And because fact2 call fact1, fact1, whatever is returned, it will return back to the calling function. Calling function which called fact1. Are you getting it? Fact1 was called by which function?
So here it is fact1 is the called function and fact2 is the calling function.
Exactly, exactly.
Okay.
Yeah. So this is how it takes place. So you should always remember this concept of calling and called. Whoever called it, the return will go back to that that function itself, not to, no, it will not directly jump to main.
Ma'am,
Okay. Yeah.
ma'am, in short, they are dependent functions.
Yes, they are dependent. Now, whoever is calling it should go back to them only. Okay. Any other doubt? Okay, so this animation shows the same thing, but I think that picture has made it clear, right? That drawing has made it clear to everyone how it works.
Yes, ma'am.
Yeah. So now what are the advantages of recursion? One advantage is given here. So like the factorial function, this particular problem, factorial problem, can be solved using iteration also, right? Using loops. Loops are also known as iteration, right? So, but the code looks short and elegant. That could be an advantage of writing recursive code. Some people like to write recursive code, so it looks elegant. It's short, right? So this is an example of the factorial function. This is with while. You can do it with for as well, of course. But it looks short and elegant. So that could be an advantage, we can say. Okay. But there is a price for recursion that we need to pay. And the price is function calls, because what has happened is I told you in the background, every function is running, right, separately. So since every function is running separately, it is consuming a lot of memory, right? So if the number of recursive calls is very large, if n is 3, n was 3, what if n was 1000? Okay, so there will be 1000 such calls, and the memory will be occupied, will increase, right? Okay, and it will consume more time because you're jumping back. Whenever there's a function call, there's a jump from memory. So from one memory location to another memory location, you're jumping, and then since there's so many function calls, you're jumping, and the time consumed is more. Okay, and if you write a recursive version of it, if you write an iterative version of it, if you write a loop, then in that case it is in the same memory that you're running. So it's just that you're adjusting the counter, you're incrementing the counter, you're decrementing the counter. Okay, that is what you're doing. Okay, so because of this reason, high performance applications, they hardly ever use recursion. So all these games, simulations of nuclear explosions where there are lots of computations, recursion is avoided. Okay, in less demanding applications, recursive is an alternative for iteration. Okay, but for the right problems, because right problems, what do I understand by right problems? Those problems which are naturally recursive in nature. There are some problems which we see in the real world which are naturally recursive in nature, and it's more easier to write down code which is recursive in nature. Okay, so there are, for example, when we talk about when if you learn data structures, if you happen to learn data structures, then in that case binary trees. Okay, binary trees are a data structure which use for most of the operations. We use recursive functions because it is very natural to express that problem using recursion. Okay, so when those of you, maybe the IT students, will be studying data structure, so you will be using recursion there. Okay, so if you're using iteration, we know that we should be careful about writing loops, right? We should not make mistakes, and we should such that our loop turns out to be infinite in nature, right? So for example, this is an oops moment for an iterative function or an iterative solution that we are writing. Okay, what is the problem with this? What is the problem with this for loop?
It will go to 9 and it will jump to 11.
Exactly. So it will never terminate, right?
Yes.
Okay. Another example. This loop is also not going to terminate. because the value of result is always going to increase only, right? Because you are writing a plus plus and your condition is greater than 0, right? Yes or no? So this is what we need to avoid. Yeah, this is what we need to avoid in case of loops, right? Whenever we are writing loops, we have to be very careful that we do not write an infinite loop in the process. Okay. In recursion also, this is possible that we uh, create an infinite chain of recursive calls, function calls. It is possible. Okay. For example, this particular function that is written here. Okay. This is okay. Looking at it on the surface, it looks correct. Oh, the factorial, the recursive formula is correct. But what is missing in this function?
True condition.
If fact
Yes.
equal to 1.
The stopping condition is missing, right? When the smallest solution we need, because it needs to stop at some point. Otherwise, it will keep on going. It will not stop, na? Because that if else is not written here. Okay. There is no termination condition. The stopping condition is missing. Okay. And what about in this case? What is the mistake here?
Num plus 1, num minus 1.
Exactly. So the condition is written, that is also there. You know, the this condition, stopping condition is there. Recursive formula is there, but the recursive formula is wrong because the recursive formula will never reach that uh, if part. Na? It will never reach that case because it is num plus 1. Okay. So you have to be careful while writing recursion as well. And these are the points where you can make mistake. First point is you're forgetting the termination condition. You're forgetting that smallest version of the problem. Okay. If you don't do that, recursion will be infinite. Second is you have taken care of that, but you have written a wrong recursive formula, which will never converge to that particular case, the smallest case. Okay. So these things we should keep in mind when we are writing recursion. Okay. So recursive function must contain at least one non-recursive branch and non-recursive branch. Na? That is non-recursive because there's no function call. Non-recursive means there's no function call. It's a constant that you're returning or some variable that you're returning. There's no function call. That is non-recursive. And the recursive calls must eventually lead to a non-recursive branch. Okay. Now, one more thing is there are some terms for representing for that smallest version. That term is known as the base case. Okay. So it is known as a base case. Base case is nothing but smallest value of the problem where recursion stops or recursion terminates. Okay. That is a base case. It is known as a base case. You will come across these terms. These are the technical terms for that. This is the technical term. And the second, that is known as the recursive formula or the recursive case. That I have already told. Recursive formula, where you write the recursive formula. I think recursive formula you must have written in mathematics as well sometime, right? Okay. Another example. So factorial is done. Another example is the Fibonacci number.
Once again, can you show the previous slide?
Ma'am, the Pascal triangle will also be have to be written using recursion, right?
You can write it both ways. You can write using an iterative. See, every solution, every problem that you have, you can write an iterative problem that you have can be written using recursion. But some problems are more natural to write using recursion. Some other problems are more natural to write using iteration. Okay. Some can be written in both ways. Both are easy. So then it depends. Then you have to think of memory and time. You know, as a programmer. So what kind of an application you're building, it depends on that. Now see, whatever problems we are discussing, they're very typical classical problems that we discuss. But in a real world
Recursion
project
versus
that you're
iteration, which is more efficient?
which is more efficient, that depends on the problem that you're solving. Okay, but recursion in general consumes more memory. Okay, so if you're going for building a game and all that, then in that case you should not go for recursion. Okay, iteration is more efficient. Now efficiency in terms of memory and time, then it is iteration. But if you want to, if it's very difficult to write a program, like for example for a binary tree, okay, I told you it is very easy, very natural to write a recursive solution to, so you will prefer recursive solution because you can think recursively. Okay, for some problems it's natural to think in a recursive fashion. You can always express it in a smaller version of itself. For a binary tree, it's very difficult to write the solution. So difficulty in terms of programming comes into picture, you know. Your programming skills might not be that enhanced to write a iterative version for that problem. There are some problems like that, where the iterative version is difficult to code, right? Okay. But memory, if you talk about, definitely recursion is bad.
And what was the mistake in last problem?
The last slide, this one.
Yes, ma'am.
Yeah. So in this case, number plus 1 you have written, na? So number plus 1 will always keep on increasing the number, and your
Okay,
base
okay.
case is
Okay,
less
ma'am.
than
Got
equal
it.
to 1. That was a problem. Yeah.
Ma'am, in the examples that you've given, a recursive function, what I get is the function that keeps calling itself. So if I put, say, I call another function, main calls A calls B, and B calls C, is that also a part of recursive itself?
No. That is a separate call, na? So that is not recursion. Recursion is itself the keyword that you should look for, calling itself, a function calling itself,
Okay.
smaller versions of itself. That is recursion. Okay.
Okay.
So now second problem is Fibonacci numbers. For Fibonacci numbers, this is a series. Okay, this Fibonacci numbers is a series which occurs like this. So what is the relationship in this series? Is that if you look at any number in the series, okay, it starts with 0 1. Sometimes people write 1 1 as a series. Okay, each number, if you look at any other number apart from the first two, any other number is equal to the sum of the preceding two. Have you discussed Fibonacci series somewhere? No, no, we have not discussed. Yeah. So 0 plus 1 is 1. So if I go for this number 5, if I want to find this number, I do not know what this number is. But I have these previous two numbers. So if I take the sum of these two numbers, I'll get 5. Okay. If I need to find the next number, then in that case, sum of 3 and 5 will give you the next number. Are you getting it? Where each number is the sum of the preceding two numbers. That is known as a Fibonacci series. Now in this, so what is the relationship? First thing is that we should know that I know that first two numbers are 0 and 1. So I say f of 0 is 0 and f of 1 is 1. Okay. So what is the recursive formula for this? It will naturally be n minus 1 plus n minus 2. If I want to find f of n, it will definitely be f of n minus 1 plus f of n minus 2. Yes.
Yes, ma'am.
Yes, ma'am.
So now we have to write the recursive function for this. How will you write it? Tell me, how will you write it? So suppose we have to return the number, okay, Fibonacci or fib, whatever, fib, let us call it fib. Then in that case, n. So fib of 0 is 1 and fib of 1, fib of 0 is 0 and fib of 1 is 1. So in that case, how will I write it? C function, that is what I'm asking. These are the base cases. Now, instead of one base case, there are two base cases here possible. For some solutions, for some problems, there could be multiple base cases, because in this it requires, right? Because first number is 0 and second number is 1, which we know, and then third number onwards we will start computing using this formula, right? So these are the base cases, two base cases, and this is the recursive formula. So tell me what will someone can volunteer? Any one of you can volunteer?
Return fib n minus 1 plus fib n minus 2.
No, this if else कहाँ है?
मैम
ये तो फिर
मैम पहले दो मैम फर्स्ट टू कंडीशंस वी हैव टू पुट इफ n equal 0 return 0
return 0,
then if n equal 1 return 1 and then out of the loop else
return
else fib equal to
no, fib equal to no, return only. Return statement only we write. See, don't look at the left hand side. Whenever you're writing return statement, the trick how to write. Forget the left hand side, just write return 0, return 1, return this. Are you getting it? Whenever you're converting into C code, now don't write like this. F fib of 0 equal to 0. ऐसे नहीं लिखना है ना. What do we write? We simply say return and the value. The right hand side we write return and the value, return and the formula. Right?
yeah.
Return fib n minus 1
n minus 1 plus fib
plus
n minus 2 fib n minus 2
fine. Okay, now how this works, the same way it works. Okay, now only thing is here this might get a little confusing because there are two calls which are running, right? Two calls to the same function in a particular function. There are two calls. It's not a single call, there are two calls. So how does this work now? Okay, so you can see the picture on the left hand side. It tells you how it works, because there are two function calls. Fib n is fib n minus 1 plus fib n minus 2. Then n minus 1 calls n minus 2 and n minus 3 and so on. Okay, so if it is fib 4, then in that case fib 4 will have calls to fib 3 and fib 2, right? Fib 3 will have calls to fib 2 and fib 1, and fib 2 on the right hand side will have again to fib. Are you getting it? It gets confusing here because there are multiple calls to the same function, but remember all of these are different copies. They're different memories. They're parallelly independently executing. Okay, now so see, you can see some results here also. So fib
Ma'am,
4,
that both fib2 will consume a different memory.
yes.
Okay.
Okay, so fib goes down to the base cases, right? So when the base case is encountered here, so fib 1 is encountered here, this is a base case, it returns 1. Okay, similarly fib 0 is encountered, returns 0. So wherever the base cases, you can see the values written here. So now how it works, again it is shown here. Again this will make it clear. So fib 4 calls fib 3. Okay, now fib 3, again it will run. Fib 3 will start running, so that condition is false. Both the base cases are false. 3 is not equal to 0, 3 is not equal to 1. So it calls a recursive formula, right? On the left hand side, fib 3 is equal to fib 2 plus fib 1. So that is what happens. Now fib 2, you are in fib 2. Fib 2 is going to call fib 1 plus fib 0. Okay, now fib 1, see, so you're seeing the left hand side of this tree. This is a tree like structure now that we have. Left hand side is running, and then what happens is this gives you a value. It terminates and gives you the value. Okay, and then what happens? Fib 1 value you get. Fib 1's value will 1 will be substituted, right, in the equation. Okay, so it gets that value back. Then what happens is the right hand side of the tree gets executed, right hand side, because in the formula what happens is first function call, whatever you write there, whichever is the first function call, see it is like fib n minus 1 plus fib n minus 2, right? So whatever is the first function call, that will be executed first. Okay, that will stop, and then the right hand side will be executed. So right hand side gets executed, it returns back 0, and then that answer 1 plus 0 goes back to fib 3. The same thing happens. Is this confusing? The same process happens. Okay, fib 3 returns back to fib 4, and then left branch of fib 4 is done, so right branch will now start executing. Okay, that is how it works. Okay, let me if it was not clear, was it clear, or you can do it, or do you want me to explain it? Tell me. Hello?
Ma'am, explain it once more.
Yeah, I'll use this. So what was happening is our first call was fib 4, right? Fib 4, you had written this plus fib 3 plus fib 2 ऐसे था. Okay. Now in fib 3, everyone has understood how it is going down, right? So fib 4 has fib 3 plus fib 2. Fib 3 calls fib 2 plus fib 1. Fib 2 will call fib 1 plus fib 0, right? Now since these are all base cases, I'm stopping the tree, right? It will not go further down because these are base cases I've reached. Okay. Now this part is not reached. This will be like this. Again, fib 2 will call fib 1 plus fib 0, and now the base cases have reached, right? So we'll stop. Base case of this is 1, right? This is 0, this is 1, this is 0, sorry, 1, and this is 0. Now what happens is how it runs. So first call from main is fib 4, say. From main you have called fib 4. So this fib 4 is calling fib 3 and fib 2. But which is the first call in the formula? See, it is left to right, right? When you write this particular formula, it is fib 3 plus this kind of an expression is written. Go on. Okay, there's a problem. It's not working. Okay. My pen has stopped writing for some reason. Okay, so what we will do is maybe I might not be able to explain right now. We are running out of time. Okay, so fib, let me see if I can. Wait, is it stuck? Something has happened. Hello, can you hear me?
Yes, ma'am.
Yes,
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 ma'am.
ma'am.
Yes, ma'am.
I'm not able to switch. Something has happened to the app. Okay, so what we can do is we'll discuss this in the next lecture, maybe tomorrow. That will be better because I'll continue with this discussion. I will talk about how it is working. I'm not able to change this right now. Okay, so we'll discuss this. We'll continue in the next lecture tomorrow. Okay,
Okay,
we'll
ma'am.
see more examples as well. Fine. So you all can leave.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Hello, ma'am. Ma'am,
Yes.
ma'am, when will be getting our ISC marks?
Yeah. By today evening, it will be displayed.
Okay, ma'am. Thank you.
Hello, ma'am.
Yes.
Ma'am, that fifth 3 and fifth 2 are the nth term, or which are they, means no, actual number 3, 2? Because 3 plus 2 is not 4, na, so I was getting confused.
They are the calls, the function arguments to the functions.
Means they are terms, right? Nth term means the
Yes,
term, two
yes, yes,
terms
yes,
before 4, na?
yes, yes. Fib of 0 is the means the first term. Fib of 1 is the second term. Fib of 2 is because that is how it is working. Na? In this case, 0 is
Yeah.
starting from 0.
Okay, thanks.